Okay, so we've seen how we can use Pythagorean theorem to solve some simple problems, like finding out whether or not something is a right triangle, or finding one side if we're given the other two sides. Let's look at some applications that are real-world applications where we could use them in real life. That's what you guys always ask me. How am I going to use this in real life? Well, here you go. Bethany has a circular tabletop that she needs to carry inside her house. So let's kind of underline, or in this case, we're going to highlight some things. Bethany has a circular tabletop that she needs to carry inside her house. Her rectangular front door has a width of 36 inches and a height of 80 inches. If the tabletop has a diameter of 86 inches, will it fit through her front door? So they always want to start you off with these little gimmicky things about how to collect data. I don't care how you collect the data. Just do it, right? Think about the problem and sort it out. Most of the time, I will always start with a picture. The picture begins to tell me what I know. So that's what I'm going to do. I don't care how they have their thing organized. I'm going to do the thing that makes it most sensible for me. So let me start off with, I know that Bethany has a circular tabletop. Right? So we got a tabletop that's a circle. That's not a very good circle, but it's a circle. And she needs to get this bad boy inside her house. And so she's got this rectangular front door. Right? So she has a rectangular front door, and that rectangular front door will make it look like that. And it has a width of 36 inches, so it's 36 inches here. Right, so there's 36 inches wide, and then it's 80 inches tall. 80 inches tall. Make that clearer. 80 inches. And the tabletop has a diameter of 86 inches. Well, the diameter is the distance from one edge of that table to the other when it is at its largest point. So the diameter is the largest point on that table, the largest distance across it. So that is 86. That is the widest that table is going to be. And I want to know, will it fit through her front door? Will it fit? Well, in order for me to figure that out, I've got to figure out if there is a place, if there's a way for me to squeeze that thing through the door. So what do I need to know? 6 inches through there somehow. Doesn't matter how. Got to figure out how to do it. So I know that it won't fit if I try to fit it in. If I just try to go in like this, it's not going to fit, right? It just won't do that. It won't fit because it's only 36 inches wide. And even if I turn it on its side, it's only going to fit like this. It's only going to fit like that. It can't because it's only 80 inches tall, and this table is 86 inches tall. So it's this huge round table. So I need to figure something else out. Well, I do know that I could try to increase my distance by doing this. I could go from here to here, and that'll give me a little bit of distance. Well, let's see how much that is. That is a right triangle, and I know how to use a squared plus b squared is equal to c squared. That's one of the things that I know, so I'm going to put that up here in that little place right there. A squared plus b squared is equal to c squared, and yeah, I think that'll do. So what I'm going to do is I'm just going to do my calculations. So I'm going to call this a right there, and I'm going to call this b, and my hypotenuse, of course, will be c. So a squared is 36 squared plus 80 squared is equal to c squared. So I'll punch that in my trusty dusty calculator, 1,296. And I'm going to add 80 squared to that. So 80 squared is 6,400. 6,400 will be equal to c squared. So what's that all equal to? Well, 7696 is equal to c squared. Now, I don't want to know c squared. I want to know c. So I'm going to take the square root of both of these things. So I'll take the square root of this and take the square root of that, because that will give me c. And over here, the square root of 7,696 is 87.7. Now, my question was, is the door wide enough to fit 86 inches? Well, yes. In fact, it's 87.7 inches if we go from here to here. So that means if I turn that table at an angle, it will go through. So the solution is yes. Or something like that, right? You can explain it in your own way. And there you go. That's one question answered. Problem number 2. Greg plays baseball at a field where the baseball diamond is a square. So that's important to know. The baseball diamond is a square. So let's see. We want to make that a second. We'll make it a square here. So I'm afraid my little marker is going to be too big. Baseball where it is a square, right? So we'll trick that there. And Each side is square. It measures 90 feet. So on each side of the square. So I'm going to go ahead and I'm going to draw this picture. I've got a square. And it's not going to be a perfect square because I'm not a great artist. But I know that each side measures 90 feet. So this will be 90 feet. And this will be 90 feet, and this will be 90 feet. That'll be 90 feet. If the baseball was thrown from home plate to second base, so that's going to be this distance right here for anyone who's played that. From home plate to second, and then it says from second base to third. So second base to third here. Then how many feet did the baseball travel? How many feet did the baseball travel? So that's what we want to know. How many feet? How many feet did it travel? And it tells us to make sure that we round to the nearest tenth. All right, so we can see that we want to find out this distance, right? Well, that does turn out to be a right triangle because it says that this thing is a square, which means that all of these angles are right angles, right? All of them are right angles in a square. And we are, once again, finding this distance as it travels from here and then over to there. All right, so let's figure out the measurement of our triangle. We know this side is 90. That means that this side is 90. So we have two sides of our triangle. We just need to find the hypotenuse. Break out the trusty-dusty Pythagorean theorem. A squared plus b squared is equal to c squared. Well, a squared is 90 squared. And then b squared is 90 squared. What is c squared? We'll punch in our calculator. What is 90 squared? 90 squared is 8,100. So I have 8,100 plus 8,100. That's going to be equal to c squared. So, plus 8,100. And we take the square root of that. And that gives us, when we take the square root, this, by the way, is 16,200. Right? Is equal to c squared. Oops. And we want to take the square root of both. And so that is going to give us a c of around 127. It says round to the nearest tenth, so 127. And it's 0.27. So I'm going to round that to the nearest tenth. So that's going to be 127.3. So c is equal to 127.3. Now, that does not tell me how far it's traveled. That only tells me this distance right here. This is 127 here. What I need to know is how far did it travel. So, we're going to go with 127. Again, that's 0.3. I didn't round to the right number. So 127.3 plus 90. Well, I'll add that to 90. And that's going to round to 217.3. So my final answer is 217.3 feet. So I'll write my solution. How many feet? It all traveled. And I'm going to put this approximately sign. Approximately 217.3. That's it. So you can fill in the I know and I need to know. I do all of that with my pictures, and you're welcome to do the same. That's it. Problem number 3. Melissa wants to put a ribbon border around a sign in her classroom that's shaped like the right triangle before. So there's our sign shape. If ribbon costs 0.82 cents per foot, how much will it cost her to buy the ribbon for her sign? This is going to require a couple of steps, right? Because we need to do a couple of things. First, we're only given two sides of our triangle. So if we're putting things around this shape, then I am going to need to know this side length. Now that happens to be c. I can see that's hypotenuse because it is across from the right angle. So I'm going to need to find c. But not only am I going to have to find c, she wants to know how much it's going to cost. And we know it costs 0.82 cents per foot. So for every foot as we travel around here, she's going to pay 0.82 cents. So we're going to have to multiply 0.82 times the total number of feet. So let's get busy. And we'll start by calculating this side here. Well, we know, again, that a squared plus b squared is the way to go. Because we've been given an a, we've been given a leg over here, we've been given a leg over here, and we're looking for the hypotenuse. So, a squared is going to be 36, because 6 times 6 is 36. And b squared is going to be 64, because 8 times 8 is 64. And that will be equal to c squared. Well, that's 90, that's 100. 100 is equal to c squared. And I know that I'm going to take the square root of both of these, and the square root of 100 is 10, and the square root of c squared is c. So I know that c is equal to 10. So now I have all of the side lengths, right? This is 10 feet, 8 feet, and 6 feet. So I'm going to have to buy, or Melissa is going to have to buy enough ribbon to go all the way around this thing. So that's going to be 6 feet plus the 8 feet plus this feet, 10 feet down here. So that's 18 plus 6. So, and for each foot, it says per foot, she's going to pay 82 cents. So I've got to multiply 24 times 0.82, right? And I could go through all that, but fortunately, I've got a calculator. That's going to give me $19.68. She is going to pay $19.60. So I could write that out. All done. Since there's not enough time to do every one of these problems, we're going to pick the ones that are most common. So let's do number 5 here. We'll do number 5. A square sandbox in Trish's backyard has an area of 81 square feet. Find x, the diagonal length of the sandbox. So most of our picture is already drawn for us, right? So we've got this sandbox, and it has an area of 81 square feet. Now remember, area is the whole space that takes up the middle of this thing. It's not the distance around it, that's perimeter. I'm looking for the area that fills up the space, so that is area. It has an area of 81 square feet, and how do I find that? Well, I'm going to multiply length times width. So I know that the area is 81 square feet, and the length and the width of a square, since we know it's a square, the length and the width are the same. So this is the side, and this is the side. So I know that 81 is equal to the side times the side, or the side squared. What times itself gives me 81? That would be 9. So s squared is equal to 81, so s then is equal to 9. There we go. Now that's important. That means I know that this is 9 square feet, or rather 9 feet, and I know that this is 9 feet. I now need to find the diagonal length. So I need to find the diagonal length, which is here. And I'm going to use a squared plus b squared equals c squared. Thanks, Pythagoras. All right, a squared is 9. 9 squared is 81. So 9 squared plus 9 squared is equal to c squared. It's going to be 81 plus 81 is equal to c squared. And 81 plus 81 is 162. And I need to find the square root of both of these. So the square root of c squared, of course, is c, always. And the square root of 162, that will be about 12.7. 12.7, if we round it to the nearest tenth, 12.7. Not feet squared, mind you. This is just the length, so this is just feet. Feet squared is when we were considering this whole space inside. This is just one length. Here are two classic problems. Number 6, to travel to her friend's house, Julie normally walks 63 yards north and 16 yards west, as shown. So she's traveling north here and then west. How many yards shorter would it be if she just took the diagonal shortcut, right? What about this? Well, what do I want to know? I want to know the distance from here to here. That is the hypotenuse of a right triangle with 2 legs. So I'm going to do this. A squared plus b squared is equal to c squared. My 2 legs are 63 and 16. So 16 squared plus 63 squared is equal to c squared. Well, let's do a little bit of work on that. 16 squared is equal to c squared. So I'm going to add those together. And I'm going to get 4,225 is equal to c squared. So c squared is equal to this large number here. And we're going to take the square root of that because we have a calculator and we wouldn't want to try to find this any other way. So it turns out that when I take the square root of both of them, I get the square root of c squared is c, and I get the square root of 4,225 is 65. That means that this side length right here is 65 feet long, but it does not ask me how long it is. It asks me how many yards shorter would it be if Julie took the diagonal shortcut. So how many yards shorter would it be? Well, I have to add these two together first. So normally if I took this route, if I went from here to here and here to here, that would be 16 plus 63. So 63 plus 16, it's going to be 979. That'll be 79 feet. But if I go from here to here instead, I'm only going to travel 65 feet. So 79 minus 65. Well, 75, let's see, 79 minus 69 would be 10. And then I add 4 more to that, so it'd be 14. And that is how much shorter, how many yards shorter. Yep, because all of this is measured in yards. I might have said feet accidentally earlier, but it's in yards. There you go. Last one. If the perimeter of square 3 is 36 units. Once again, let's remember what that means. That means if we go around this square, the perimeter, the whole distance around it, is 36 units. So 36 units all the way around. And the perimeter of square 2 is 48 units. So once again, that means if I go all the way around like this, I am going to travel 48 units. So there we go. Now I want to know what is the area of square 1. Well, how does this help me? Oh, I have some scribbly things here. How does that help me? Well, let's look and see. So I know that if the perimeter, right, we said the perimeter around this thing was 48 feet, 48 units, then that means that each one of these sides is going to be 1/4 of 48. So I need to divide 48 by 4. How many times does 4 go into 48? Well, it goes in 12 times, of course. 4 times 12 is 48. So that means that each one of these sides is 12 feet. So that's 12, and that's 12, and that's 12. And hey, look at that. That one's 12. That one happens to be the leg of a right triangle. That's helpful. Right? So over here, what about this? Well, this is 36. That means that each one of these sides is 1/4 of 36. Well, what is 36 divided by 4? 36 divided by 4 is going to be, 36 divided by 4 is going to be, I think we all know that. That's going to be 9. 9 times 4 is 36. So this will be 9 up here on this side. All these will be 9. So we've got 9 and 12. So we have an a squared, right? A squared plus b squared is equal to c squared. We'll take a, we'll call that 12. 12 squared. Plus b squared, which we said b was 9, right? Because of the side lengths there, 9 squared is equal to c squared. So that's 144 for 12 squared plus 30, whoops, that's 81 for 9 squared. And that's all equal to c squared. So 144 plus 81 is 225, I think. It's getting loud out there. Plus 81. 225 is equal to c squared. And you might be able to figure that out in your head. 225 is the square root of 225 is 15. So what does that mean? Well, that means that this side right here, is 15. And I want to know what? I want to know what is the area of square 1. So I don't just want to know this side. I want to know the area. I want to know about all the space that fills this guy up in here. What about the space that fills that guy up? Well, let's see. That would be length times width, because the formula for area of a rectangle, we've talked about this before, the area of a rectangle, or a square rather. Square is a type of rectangle. The area of a square is length times width, or side squared. And since this is a square, I know that this side is 15 and this side is 15, so I'll just square 15. Well, that's 15 squared, which I just calculated over here. That is going to be equal to 225. So what is the area of square 1? The area, this whole space that's taken up in front of there, the area is equal to 225 units squared.